Good afternoon. How is everyone today? Good? You guys look tired. All right. My name's Jake Kouns. I'm with Risk-Based Security. Kymberlee Price, this side. With Synac, we're here today to talk about third-party code and fixing all the things. And I was just being told we're getting heckled on Twitter that all the things are broken, so we'll go from there. All right, so we want to set the stage a little bit and just talk about, I think everyone can sort of agree that everyone's under pressure these days. Companies out there are being told that they have to figure out better ways to sell, to address their clients, all that good stuff. Competition is fierce. Deadlines are here, right? IT's really being the ones that are being told, hey, we have these crazy ideas these marketing folks came up with. Go build this and get it done. And there's deadlines, so make it happen now, right? And typically, this whole better, faster, cheaper thing, right? Companies now, instead of, sort of what used to be, hey, you could pick 2 of these, now people are saying, look, we want all 3. Just go get it done. We want it cheap and we want it done fast, and we could care less about all your little excuses. Go make it happen. And this has become the new normal, right? So what do most people forget? There's a hint, right? Security. It's a complete afterthought. At the end of the day, it's products, it's features, it's all that good stuff. Have you heard about companies losing a sale because security wasn't built in? No, but this little feature, widget, or gadget, or whatever, if that's not there, it's a problem, right? So you can see where the focus is, and you can see why they forget it. So again, what it comes to is these development realities, again, what people will call the iron triangle, again, that cheap, better, faster, cheaper. The reality is usually people will say, hey, you can pick 2 of these. Some could argue that as well, but you could pick 2. But when we go back to the we want all 3, right, and that little circle in the middle basically says it's non-existent. And so that's a big struggle these days. And so what we're finding is that third-party libraries are really trying to come to the rescue, if you will. So developers are trying to figure out ways to get things done much faster and not have to rewrite stuff and all this good stuff. So they're using third-party libraries in their code. Speeds up the development process, don't have to rewrite a bunch of stuff, and in many cases, developers believe that, hey, if I'm using this well-established piece of software that's been out there for years, clearly it's amazing code, I can just do whatever I want and call it, and I don't need to think about security because it's already well thought out in these third-party libraries. And so this is something that we continue to see over and over. So what's the real problem here, right? Well, it sounds pretty good, actually, right? Don't have to rewrite stuff, just use these libraries, things are great. And I think that's what the whole issue is. People aren't really sure what the problems are right now, struggling to try to figure out what's going on with third-party library. Organizations are trying to get their heads wrapped around just what's happening. So there was a report that came out from Secunia in 2014 about vulnerabilities in 2013. I'm going to read this to you. It says, third-party programs are responsible for 76% of the vulnerabilities discovered in 50 most popular programs in 2013. Most people had no clue what that meant. A lot of people started looking at this and relating this to third-party libraries. The problem is when you looked at the report, first of all, the report was really flawed. Sort of the methodology was off. It didn't really make a whole lot of sense. But it had nothing to do with third-party libraries, even though people were trying to use these quotes talking about third-party libraries. This was really talking about third-party products, i.e. non-Microsoft products, these programs being installed. So it really wasn't even the same thing. So then if you look further, this is a bad eye chart for some of you back there, but this is from OSVDB. This is looking at vulnerabilities over time. The key point here is that we're seeing around, I'd say about 10,000 vulnerabilities a year, and we're not seeing much of a slowdown now. And what's really crazy about this is that, obviously, other than us producing just really shit code over and over and over, and it doesn't seem to be getting any better, at the end of the day, this is sort of a blind spot in here too, is that we're not even talking about site-specific vulnerabilities, multi-tenant cloud type stuff. This is just tracking vulnerabilities in software and code that you can sort of download, right? So seeing 10,000 vulnerabilities a year is sort of concerning. When you slice it a little bit further, what is even more concerning is that we're seeing sort of cross-site scripting, SQL injection as, you know, two of the most prevalent vulnerability types that continue to happen, right? These are 101 type vulnerabilities that I feel like we've been talking about for the last 10 years that should be eradicated by now, but they continue to happen over and over and over and over again. So it's pretty sad, right? So then we have Heartbleed. We have a fancy logo that comes out, and everyone all of a sudden starts freaking out over this, right? Everyone loves the Heartbleed logo? Yes? You have to admit it, right? So a fancy logo can go a long way, and that was sort of the first time that you started hearing people talk about things like OpenSSL and what are these third-party libraries. Prior to that, it was sort of not much going on. So clearly after Heartbleed, there were no SSL issues with OpenSSL, right? Because we haven't heard about them. There's no fancy logos coming out for them, and they weren't all over the news, which Heartbleed was, right? So who believes there has been no more vulnerabilities in OpenSSL since it came out? Was that okay? So here's all the issues in OpenSSL, and we'll wait for it. This will pop in down here at the bottom. This is where Heartbleed was back in April, right? And so since then, we're talking about 15 new vulnerabilities in OpenSSL. Whether you love or hate CVSS, we won't get into that today. But, you know, an average around 7 score there and a maximum of 10. I think there were 2 of them. Another one was around 9.3. So one could argue that these vulnerabilities were way worse than even Heartbleed was, right? So has anyone talked about OpenSSL since then? A little bit here and there. Has anyone actually gone out and patched OpenSSL after the fact? I mean, everyone jumped, well, maybe not really for Heartbleed, but we're not seeing sort of this continued focus on these sorts of things, right? And then this week, a post comes out to OSSSec, right? This bash vulnerability, right? This doesn't look very sexy. I don't think you have to worry about this one, right? So pretty much immediately we started saying we should update our slides. We like the term bash hole for the vuln. I think that's a much better one personally. And you can see here we said need logo ASAP, right? So hit the Twitter, try to get a logo. We're pretty awful at graphics, so this is as far as we got with bash hole. And then, you know, after we started chatting about it pretty quickly, you started seeing more things. And Robert Graham's been scanning the internet forever. He came out, started talking up shell shock, which, meh, shell shock. Bash hole's so much better personally. But shell shock is basically taken over. He's going to pay for a logo. I don't know. But then, even before he gets through with that, someone else had already created a logo and called it Bash Bleed. So I don't know if you've seen this one yet, but this one looks pretty cool. A little off topic, but all vulns need logos now. Seriously. And no excuse, right? You can go out to Fiverr.com for $5 in 48 hours or less. You too can have a vuln, logo for your vuln. And until sort of we create some sort of random name and generator logo thing, just get some logos there. All right, so back to Heartbleed. A 5.0 sort of on the CVSS score, right? Why do we think it took off so much? You guys have any thoughts on that? Why did everyone all of a sudden start talking about this thing? Yeah? Large attack vector. All right, so we start to get into these larger vectors. I personally think the reason why it sort of rocked everyone's world was this fact that we have been training our users forever that the internet's a very scary place, right? It's a doorway into every dark alleyway in the world. But if you're on the web and you look and you see this little lock icon, you're okay. Life is good. And now all of a sudden we've told all these users that even though you see that little lock icon, you're screwed, right? This Heartbleed thing's going to get you. And so that sort of seemed to really resonate with a lot of people, right? But it did infect a lot of people, like we were saying. It's sort of out there, right? So estimated 100 plus vendors. People could argue a lot more, give us grief about that. 600 plus servers or more. Who knows how many organizations were impacted by this, but a ton, right? So one vulnerability affecting a ton of folks. Here's a worse eye chart. Apologies for that back there for you guys, but here was like 68 of them, and then we got tired of typing them in, of vendors. And in most cases, people will start thinking, well, OpenSSL, it's got to be sort of cheap startups or like open projects, people that can't afford, people don't really care, right? And then you start looking at like major companies using OpenSSL, right? Cisco, Juniper, HP, BlackBerry, Oracle, the list goes on and on. So this isn't just sort of, yeah, I can't afford things. These are major enterprises that are using and relying on OpenSSL. And so what that gets us to is this concept of systemic risk, right? Sort of one sort of event can cause multiple problems, right? Everything's interconnected. And when it comes down to it, a lot of people can relate to when they think about hurricanes, right? You know, one sort of hurricane rolls in, you're talking about multiple, families and impact and all that sort of stuff. And now, for the longest time, we've been hearing all this cyber Pearl Harbor and all that sort of stuff. You're starting to hear the cyber hurricane of one event, one vulnerability going across multiple organizations, multiple projects. So, gets all over the news. Heartbleed's out there. Everyone's talking about it. We're going to fix it. Again, Robert Graham doing scams. Started with 600. We get it down to like 300 servers that he's found. Then all of a sudden things stall out. I haven't seen his latest scan results, but at some point, we go back just to not caring anymore again, right? We patched what we could. Meh, we're done. So we're not even seeing that it was that big of a deal that we're seeing solutions all the way through. So what it starts doing is we start asking ourselves these questions. We know we need this efficiency, right? We've been talking about better, faster, cheaper, all that good sort of stuff. But at what cost does this efficiency come in? So, and taking it a bit further, it's not always just sort of one library impacting multiple organizations. We're finding that a single application can have 50 to 150 or more libraries in there. So you're talking about tons of libraries in one piece of software. So that's a whole lot of patching to keep up for development, teams, customers, etc. When trying to figure out sort of how many libraries are just out there, that's still a challenge. Not sure if you guys are aware of a company called Black Duck. They've got this awesome site called OpenHub. If you're interested, you should go check it out. So I reached out to Black Duck to talk to them, and they came back basically saying that they're tracking over 1 million open source projects across 6,000 sites. Again, not all sort of libraries as we define it, but there's a lot of stuff going on out there. Rough estimates, I guess, would be between 3,000 to 5,000 libraries we think that are out there. And continuing to work to try to identify what these things are. Another stat that they gave us, which was pretty nice, was 30% of the Forbes Global 2000 enterprise code is open source, right? So this isn't just sort of just a small little percentage of things that we're seeing. There's a lot going on. A couple other quick little bits on OpenHub stuff. It's pretty neat. You can see all the most popular projects out there, what's active. They also, we looked into, we're talking Heartbleed so much, you can look into OpenSSL, see what's going on. It's pretty interesting to see what languages they're written in, the amount of code that's in there, commits, all those sorts of things. Here's also FFmpeg, which we'll talk a little bit to. And again, just some really pretty cool stats and things that you can see how the code base is growing, what's going on, and what we're really dealing with here. And so with that, that sort of sets the stage. I want to talk a little bit of data now. I'll have Kymberlee chat.
Okay, let's bring that down a little. Hi. So what we're going to talk about next is the data that we analyze. Now, as Jake mentioned, there's a lot of third-party libraries out there. We're just going to look at 7 today, and we're going to look at the volume of vulnerabilities, the frequency of their releases, and we're also going to take a look at some of the products that consume these libraries, because all of these things come into play when we're talking about risk and potential impact on Heartbleed scale. If you want to think of it as that class 5 hurricane kind of thing. So let's start with OpenSSL, because Heartbleed is a good place to start. And when we take a look at this library, they've got 45 vulnerabilities since 2007. And I'll be honest, I have not updated this slide with the additional 15 that have come out since Heartbleed. They average anywhere from 1 to 6 releases per year, and their average CVSS score is not that high. It's a 5.39 over this large span of time. However, 87% of the vulnerabilities are remotely exploitable. And it's in a whole lot of stuff. It is in all sorts of consumer products, from Gmail, Tor, yeah, that's great. How about LastPass, Amazon's AWS, everything out there. And then I got tired of pulling icons, so it's also in all these other things. It's in multiple products that IBM makes, multiple products used by Intel, Juniper, Cisco. You've got a lot of companies using OpenSSL, and that's part of why we saw the pain coming out of Heartbleed, is because there was a lot of things to patch, and this doesn't even cover web application specific type things. So another popular open source library is FreeType. And free type is interesting not because it's really high volume. You can see we're talking about a scale of 22 vulnerabilities in their worst year, which is 2012. But 50 vulnerabilities overall. They're averaging about 2 releases per year, but their average CVSS score is just under 8. Now, the reason I picked free type to talk about is because it is used in a lot of places. Like devices. So you've got this great font rendering library that people are using because writing a font parsing engine is hard. And the problem is Jailbreak Me 3 for iOS used a free type vulnerability that was remotely exploitable and was caused by basically an input parameter was not being checked. And so you've got a remotely exploitable vulnerability in free type where, okay, you can use it to jailbreak, but I can also use it to send you a malformed font in email that if you read it in HTML format, now your phone is owned. But free type is also in the OS of Apple, OS X. It's in Webkit, which is another library used in multiple browsers. OpenOffice, StarOffice, Gentoo, PlayStation. It is used in an American Girl video game. So if you have daughters, that probably didn't get patched. Probably not having a whole lot of input of fonts into that game, but still, it was kind of interesting to track that down and be like, okay, I guess that uses free type too. libpng. Now, I'd like to point out that this is a graphics rendering library, and that's their official logo. They've got 20 releases, and this library averages 3 releases per year with 26 vulnerabilities. So what you can see here is they get a vulnerability and they patch it, and they get a vulnerability and they patch it. They don't collect up a few vulnerabilities and patch them in the next release. So if they have a particularly bad year, they don't seem to have a process whereby they say on a monthly basis or on a quarterly basis, we're going to go ahead and release multiple advisories or multiple security issues at the same time. It's just a fire it right off. Now that's really fast for them. They're getting the fix out quickly. The trade-off is, as the dev team, you're patching on a regular basis, assuming you're patching. So this one's interesting because you're hitting a lot of major vendors. The reason for this is everyone wants to be able to render images. You want to have compatibility. So you've got it in Apple. You've got it in both iOS and OS X. You've got it in multiple Oracle products, Adobe, Flash Player, VMware. Between the VMware and the BlackBerry logo there, that's the Webkit logo. Again, that's used in multiple browsers as a browser rendering engine. We've got Chrome, we've got Android, and now we've got some Microsoft products of Visio and PowerPoint, because again, you got to be able to render images. And so then we've also got Gentoo, VMware Server, Fedora, Debian, Slackware, a bunch of other things. We tracked libpng to over 130 applications. FFmpeg. FFmpeg is complex video processing software, and it's been in use for years and years. However, they've only been really publishing security advisories, according to their website, since 2010. And security advisory is a little bit of a exaggeration. They simply, in their releases, have said what is gotten fixed from a security perspective in each release. They list off the CVEs that have been fixed. So what's interesting here is that I can tell you there's 168 vulnerabilities in FFmpeg according to CVE details and the National Vulnerability Database. But when I go to the FFmpeg website to go through all their documentation and release notes, I can't find any release notes for security fixes before 2010, although I clearly have some vulnerabilities before then. So the data here is a little messy, but their average CVSS score is an 8.35, and they've got, on average, 12 releases a year, but of course that's skewed a little by the first couple years of data. So you're going to be looking at anywhere from 7 to 33 releases in the last 2 years. So that's a lot of patching, and it's also a lot of vulnerabilities. The last few libraries we've looked at across 7 years have had 50 vulnerabilities. We're now looking at scale of 80 or 90 potentially coming up in a single year, and that not being unreasonable given the numbers they put up in 2013. Excuse me. So are we seeing any trends here? Because I'm seeing some of the same logos over and over, which means Chrome's got a lot of third-party patching to do. So does WordPress. We're seeing PlayStation up here again. QuickTime, DirectX, and a number of other applications. YouTube is up here for the second time as well. Excuse me. The other thing about FFmpeg is that they include a number of other third-party libraries in them, so you have a recursive library issue where you've got about 5 or 6 libraries in FFmpeg, which in and of itself is another library. So all of those have to be updated. Alright, so let's start looking at things that aren't maintained by a community group and actually have some corporate backing behind them, like Apache, an Apache Tomcat. 88% of these vulnerabilities are remotely exploitable. Really not a great thing. They're averaging 6 releases a year. They've got 95 vulnerabilities, but their average CVSS score is pretty low. So while they are obviously, still pushing out a fair number of advisories and vulnerabilities, the risk impact is much lower than some of the other libraries we've looked at. And that's a really good thing because they're used in a lot of enterprises. We're not talking about consumer applications, YouTube, your TV, things like that. Now we're talking about payroll software. Your network, your telephony system in your office. So we have a lot more corporate and enterprise exposure here. So I guess it's probably a pretty good thing their CVSS score is pretty low. And then I got tired of pulling icons, so there's a few more. Alrighty, Adobe Flash Player. Adobe's got money for security. They have a whole security team. I've met some of them. And they have a lot of vulnerabilities, because we're looking at 358 since 2008. Technically 2009, because I couldn't find any listed for 2008. Their average, because of the 2008 data skew, is 8 releases per year, but seriously, you're looking at 10 to 12 a year. You're pretty much going to be patching monthly. And they're in not as many products as some of the other things we've looked at, but they're in some big enough name ones that they've got a lot of spread. And one of the things that's kind of interesting about Flash is back a few years ago, their Flash Player, a few years ago, there was an effort called the Open Screen Project, where they were working to get Flash Player on DVD players, Blu-ray players, televisions. And so then in 2011, they abandoned that project and instead wanted developers to focus on Air applications, HTML5. And so as a result, they're still supporting Flash on those platforms, but when's the last time your Sony television prompted you for a Flash Player update? Probably haven't seen that in a while, so don't know how secure those actually are. Don't know how realistic they are to exploit either, but it's some interesting data. Oh, and to step back really quickly, on this slide, we don't have a CVSS score average, and that simply comes down to the data is a bit messy, and it's going to take some time to do quality sanitization, and I didn't want to present data to you today that I didn't feel really solid about. So we'll be doing this talk again in the future, I'm sure, and we'll get it updated by then. Okay, Java. Go big or go home. I took on a big one. And now all of a sudden we've got a y-axis that pops up to 200 because 2013 was a really bad year for Java. They have 465 vulnerabilities, but they only average 4 releases per year. So quarterly with a few occasional emergency updates. So from a sustainment perspective, this one's going to be a lot easier to stay on top of for patching. This one also has some of the same challenges with CVSS scoring. Simply trying to be sure that I'm giving really accurate data, and I just need a little more time to finish crunching through all 465 vulnerabilities. So I'm tired of pulling icons for where things are, and Java's really big, so let's talk about where it's not. It's not in bananas. It's not in bath towels. It's not in cats or hats, although I've seen some hats here that may not be true for. And thanks to a lawsuit, it's not in Microsoft products either. So I'm going to let Jake take the next section.
All right, so hopefully some of those libraries you're familiar with, starting to see a little bit more or the problem here. So we've sort of painted a picture of what's going on, made things sort of look a little dreary. So we want to talk a little bit about what's being done now, because there are some efforts, right? So we think it all comes back to accountability, right? Trying to get people accountable for code and better code quality and staying on top of things. So, serious question. I want to poll the audience here. I'm going to make this statement and I'll see if you agree with it. Open source is secure because everyone can review it. More eyes makes all bugs shallow. Who agrees with this statement? I'm going to wait for you to put your hands up. All right, so usually there are some people that put their hands up about that. People who have some hardcore open source people believe that is legit. And it sounds good to say. It does. It feels good to say, right? And everyone who is an open source sort of proponent believes this. Everyone could look at it, but they don't, right? And so in this particular case, accountability for quality is deferred. And you can see that with some of these bugs that are coming out now that have been there for 20-some years that anyone could have found, but hasn't, right? And so that's sort of one of the things. Also, sort of what's interesting about it too is a lot of people always think it's someone else's code. They don't need to look at it. They can just use it and trust it. You know, again, the number of times I've talked to developers and we'll ask them questions, I say, no, it's just I just pass things over there and it just works and I just use it. And why would I even look into that? And that's sort of a common mentality with it. All right, so the next one. This means, since none of you in the room raised your hands, that you believe closed source is more secure because no one can review it and it's supported by enterprises. So who agrees with this one? Hey, I got one playing along. All right. So everything's broken and our quality of code sucks. Do we agree with this? There we go. The whole audience raises their hand now. And again, right, it's the same sort of thing. Bad code is just that. It's bad code. And it exists in closed source as well. And you saw from some of the data charts there, you know, those enterprise supported ones had way more vulnerabilities than some of the other ones now. Again, I'm not going to get up here and try to use vuln statistics to make any other points. That's been beat to death about how that's not the greatest thing. But just on the surface, you know, you can start to say, you know, we've got problem in whether it's open or closed source. So does it come back to show me the money? Maybe. So projects we know, and if you've messed around with any open source stuff, created your own stuff or try to keep it going, you know that they're not well funded at all. OpenSSL did share some financials and it was pretty bad, right? Not many people sort of supporting it even though these big enterprises rely on it and use it all the time. And so we're starting to see some things with the community that are popping up, right? So I want to talk a little bit about some of these. So money, that's what we need. Trying to figure out ways to get some of these critical pieces of software you know, funded or resourced, right? So we're starting to see bug bounty programs, right? So they're all the rage these days. So crowdsource more eyes on it. So again, we talked about we could have people look at it. Now let's incent them financially or swag or whatever it may be to get them to do that. We are also now seeing some more code audit initiatives coming up, right? We've seen about TrueCrypt before that vanished, and then OpenSSL, right? Getting reviews. So what are some of the results when it comes to that? Well, we saw you know, a crowdsourced sort of let's raise some money, let's make sure Heartbleed doesn't happen again. Trying to raise $100,000, I think about $7,000, and it stalled out, right? So if you look at what people care about, where they put their money, didn't really care that much to sort of contribute to this thing. So that was a little concerning. Then we start seeing that people are starting to say that, look, OpenSSL needs corporate funding. They really just, you know, I think from that time of that bug bounty raising money and a little bit more, they raised around $9,000. It's just not enough. They've come out and said that just won't help us with this complex code to do anything, right? So then we start seeing that finally some tech giants, IBM, Intel, Microsoft, Facebook, Google, more finally come out and say, look, all right, we're gonna fund some things here. That's what we're gonna try to do, try to get some of this fixed. We see something at the end of May come out called the Core Infrastructure Initiative. NTP, OpenSSH, OpenSSL. And for OpenSSL, they talk about 2 full-time core developers. And again, they're still accepting donations and all that sort of stuff. So we're starting now to see some full-time resources coming in on this stuff. And then also another bug bounty program, the Internet Bug Bounty Program, looking for sort of any issues in software that's on the web, right? So we're starting to see money trying to help things here. Now, a new initiative from Google, which is pretty noteworthy, Project Zero. Has everyone heard of Project Zero by now? Good amount of you. So this sort of is the dream team, if you will, of researchers hunting out and weeding bugs in popular software, whether it's libraries or other things that the internet relies on. And if you look at sort of one of their statements, which is interesting, they basically said, the project said, you should be able to use the web without fear that a criminal or a state-sponsored actor is exploiting software bugs to infect your computer, right? Everyone should be able to use the web and feel good about it. They're publishing all the bugs that they find. You can find them out there on the web, and as of a couple days ago, there were 48 issues that are already listed that they're working through getting fixed up. So it's going to be very interesting to see what these guys are able to do when you're taking pretty big resources, smart folks really going after this stuff. So we'll keep our eyes on this. What we're also seeing is more forking, right? Forking for quality. Sort of the premise here being that the only way to ensure the code is secure is to have full responsibility for it. So instead of contributing back into what's already there, let's fork it and do our own stuff, which is sort of eye-opening. I think it's sort of a problem that the security community as well as sort of IT in general always has. Instead of taking our limited resources and always working on something together, we always seem to want to make it our own, take something and instead of contributing. So I think that could potentially be an issue. But we've seen companies do this, right? We've seen Google do it. Google Blink, right? Sort of splitting off of Webkit. And, with them, if you looked at a lot of the progress that Webkit was making, they were the ones finding a lot of issues, really pushing things forward. So you can start to see where Google's doing that. But then on OpenSSL is another interesting one, right? We've seen OpenBSD come out with this LibreSSL saying, OpenSSL's, never going to be fixed. The only way for us to do it is to split our own stuff off. So again, it's a little tough here as we're splitting things off. So what ends up happening here? Well, the first sort of publication of the LibreSSL, there's an article that comes out. Some researchers look at it and say, hey, there's problems, right? There's issues here. And worse than OpenSSL, and in this article, things like catastrophic failure, unsafe for Linux, right? So we forked off of something that we thought was not going to be pretty good, and now the first reviews come back saying it's worse. And of course, a couple hours later, the OpenBSD comes out and said, this is overblown, and it's already fixed. So, if you think about it as sort of a customer, or developer, or consumer, what the hell do you believe, right? What's going on here? You're not even really sure what to go after. So in some cases, the forking stuff, it seems to make sense, but in other cases, it just seems to confuse the issue more and sort of instead of focusing our efforts, it just gets them worse. So, all right, we'll talk a little bit about some actions now.
Alrighty. So a lot of those actions that we just talked about have to do with vulnerability discovery, rooting out the vulnerabilities that still exist in these libraries and bringing them to the light of day so that they can be fixed. But that's only half the problem. Once we get them fixed, you still got to patch them. And that has to be baked into the security response cycle, the development process. And if your security response process involves we've been hacked, do we cover it up or shoot the messenger? You have already lost. And yes, this is a joke. Your security response process should not look like this at all. This is not part of the advice section. Incident response, typically, as a vendor, is going to look like an issue gets identified, you're going to assess the impact, you're going to look for variants, you're going to see, because bad code likes to hang out with bad code, usually you can, start tracking developers in your company who have a tendency to put some of these extra value items in for you, and you go find all those and you start working on the fix and you test it. And then you release it to the public with a CVE and you do the advisory and you support your customers and hooray, everyone is secure. Except that vulnerability wasn't in your code. It was in one of these third-party libraries we talked about, which means when they released their advisory, you got OD'd. And now you start your investigation process. It's like, oh, okay, there's a libpng vulnerability, or there's a Flash player vulnerability, and now I have to investigate how it impacts my product, and now I have to dev a fix. And if you're the IT manager, you don't get it until much, much later than when the vulnerability was actually identified. So the vulnerability discovery in step 1 is a very long way from solving this problem at the end of the second step 5. So how can we be prepared? And one of the challenges that Jake and I discovered is that when we give this talk at a security conference, there's a lot of nodding of heads and saying, yeah, this is a problem. You should go give this talk to developers. And we should, and we're going to look at that. And I hate reading a slide, but for anybody who gets these slides later, I want all of this in there. I want people to have a checklist of, before we start that new product, let's evaluate what libraries are we going to be using, and what are our options, and what are the vulnerability trends in those libraries historically. Do we have enough people to support that library choice? Do we need to go to our management and say, okay, we're going to use this library for these technical reasons, and I need one additional developer for sustainment work, because we're going to have to patch it on a quarterly basis? What's your prioritization model when the vulnerabilities come in? You don't want to try to figure that out when Heartbleed happens. You want to have that model identified ahead of time. What early monitoring processes can you put in place so that you're not suddenly like, Heartbleed, oh my gosh, we have to patch. Oh, the last time we patched OpenSSL was 9 months ago. How many other vulnerabilities have come out during all that time that we didn't fix? And what low friction areas can you identify to minimize risk? A lot of applications and a lot of products are sometimes written with full rights, and especially in mobile applications. Start thinking about, do I really need to use that? Do I really need to give this access to this other thing? How can I use sandboxing or other defense in depth technologies to minimize the impact without damaging the functionality? And of course, communication with your development team, if you're in the security space, is so super important. It's got to be a two-way communication. And unfortunately, security tends to get bolted on at the end sometimes, after the development decisions have been made. So if you can't be injected into the process early in development planning, and you're simply in the position of, I'm responsible for the security of something that's already out there, what libraries do we use and where, and how do we know this? If you're counting on a developer to fill out a database internal to your company, that's probably not going to work so well. What's in it for them? Do they keep it updated when they update the library? Aside from being bureaucratic administrivia, why would they go update that? To keep the lawyers off their backs about compliance? It's really not core to their business day to keep a website updated or a database updated with what libraries they've used. And what's more, they may implement a library, internally transfer or quit, and maybe the next person doesn't even know that library is being used. Like, there's all sorts of problems with developer reporting. Humans are very error prone, it appears. So there's some tools out there that do a great job of scanning your source code and reporting back to you, here's what libraries you use in your product. And this isn't based on a human being telling you you use it. I found it in your code, and here's where it is, and here's what version it is, and here's how many publicly known CVEs are known to affect it that you haven't patched. And so 3 of these options are Black Duck, Palamida, and Sonatype. And I'm not going to tell you which one to go with, but the legal team can, I don't say this often, the legal team can be your friend, because they want to know who's using what code where so they don't get sued. So when you go to your legal team and you say, hey, I would like some help tracking down third-party code. Do you have this data? Hey, maybe we should invest in one of these tools. They may actually give you budget, and that'll help you secure the products that you're responsible for supporting. Now, if your legal team can't help you, or won't help you, or you simply just don't have the resources to buy that kind of software service, you can still do it manually. I'm not going to lie, it's not fun, but you can do it manually, maybe do it once a year just to get a good feel for what vulnerabilities are out there. I would highly recommend more often. But there's a lot of different sources to find out what CVEs, what vulnerabilities exist in the products we use, and get a feel for what those trends are. National Vulnerability Database, of course, is one, and I don't want to diss the guys at MITRE and NIST. They do the best they can, but it is not, it's really just a vendor-reported dictionary and a single correlation place for data. Then you have other organizations that are doing some analysis of the vulnerabilities and adding additional value. Some of these are free, and some of them are not, and so your mileage may vary with each of these. Then we get to this buzzword, vulnerability intelligence. What does that mean? Does that mean last night I was hanging out down at the bar with somebody and I told them about a vulnerability I know about and now you have intelligence that might affect you? Is it a 3-inch stack of log reports sitting on your desk that if you go through, you're going to glean some amazing information that is going to forecast the future? Does it mean a consumer reports style website that rates the quality of all these libraries? That could be useful intelligence on vulnerabilities. I don't think anybody really is putting thought into, are we solving the right problems when it comes to the third-party libraries? Everyone likes the idea of we should be doing proactive evaluation of libraries. I mean, I even saw Chris Weisopel tweeting about it this week after Bash. It's very pie in the sky. Instead, we're playing whack-a-mole. We're chasing down the vulnerabilities as they come up and not very strategic about it. So this concept of vulnerability intelligence, we're not doing it in a really organized way. We're not in agreement on what it means even. And in the end, it's only really as good as what you pay for. So one of the slides we talked about earlier was FFmpeg, and I showed you how it had 168 vulnerabilities since 2008. And I talked about some of the issues with the advisories. If you look in VulnDB, there's 871. Math is hard. Jake can't count. Actually, they're doing analysis on the libraries, and they've uncovered vulnerabilities that don't have CVEs. And FFmpeg flat out admits to it on their webpage. They'll list a release, they'll put down a list of CVEs, and then they say, quote, fixes the following vulnerabilities, list, and more security issues that have no CVE number. Many of these issues can be exploited when a remote file is played back, and a few are probable arbitrary code execution. Oops. We didn't request a CVE for that, and nobody made us get one, so they're just silently fixed in there. How do you know to patch? How do you know how bad it is? How do you know how it affects you? How do you know what to watch for in exploitability telemetry? You don't. So, your vulnerability intelligence feed, whether that's, vulnerability data from a database vendor or, any vendor is only as good as what you pay for. So, what else can be done? We talked a little bit about the accountability thing. A lot of people are consuming third-party libraries, and they just think somebody else is looking at the security. I mean, there's a lot of developers consuming third-party libraries that never upstream a single security fix. And we've got to change that. When we bring in third-party consultants to pen test our products, we can't only have them look at native code. They've got to be looking at those third-party libraries, and not just how did we implement the third-party libraries? Did we screw up the implementation and leave, some sort of attack vector? But does the third-party library itself have a vulnerability, and what do we do with that? We need to have that proactive plan for patching. As Jake mentioned, we've had 15 more Heartbleed vulnerabilities. Did anybody patch them? Does anybody have any idea when they're going to patch OpenSSL again? Do they do it quarterly? Do they do it monthly? If you're one of those products that has 14 or 20 or 30 different third-party libraries in it, what's your servicing cadence? Does your development team just update all those libraries in their next major revision, their next major product release? Is it just put it in and it's done, or are they patching regularly? And if they've got that many different libraries publishing advisories on a monthly or bi-monthly basis, how do they manage that volume? So have a proactive plan for that, and a robust incidents management plan so that when the next Heartbleed or Bash happens, you know what you're doing. You don't want to try to figure out how to handle the emergency while you're in the emergency. And if you're not in a dev shop and you're the IT manager, you're thinking, well, I'm at the end of both of those waterfalls of this response process. I have to wait not only for the vulnerability to be identified and fixed by the third party, and then fixed by the vendor, and the vendor to give me a patch. Like, I'm just sitting there waiting, and I'm exposed this whole time. Network scanning. Know what libraries are in use in your products, and go push on those vendors for the fix. If you've got Debian in your environment, and you see a libcurl critical vulnerability come out, you should be calling Debian and saying, when are you going to patch that? Because I know you use libcurl, and I know you're vulnerable, and that means I'm vulnerable. And at the end of the day, you know, should the vendor be fixing it anyway? Yeah. But when a customer calls and asks for something, that causes vendors to prioritize things. It's just the way it is. We've got a whole bunch of stuff to do, but these 5 things were specifically asked for by paying customers. Boom, goes up the priority list. So ask your vendors, when are you going to fix it? Are you affected by third-party vulnerabilities? What's your sustainment plan for that? Make it part of your purchasing process if you can. And again, plan time for sustainment so that you're not trying to figure it out as you go. So we are just a few minutes early. Any questions? Trebuchets. No. So the question was, how do you win the conversation with development when they come in and saying, we're going to save time and money using third-party applications, and you know you're the person who's responsible for security. And I think security gets the sort of doom and gloom. You're always a buzzkill. You're coming in and like making things hard and expensive and slow. But developers tend to respect data. And so if you can talk to them about, okay, I understand you want to use that library. Are you aware that this is the volume of vulnerabilities they typically have, and what is your plan for maintaining that code? Because otherwise, every time they release an advisory, you're going to end up with a bug being opened by our security response team, who's then going to come into your triage and ask when you're going to fix it. And so I think that in many cases, the security team cannot stop a development team from using a library of their choice. But if we can do the best we can to educate them on what the impact of that choice is, then 6 months down the road, when you report that really bad vulnerability, they're not like, oh my God, how's this possible? You're like, yeah, we talked about this. How are we going to work it through? And it gives you the opportunity to become a trusted partner to your development team instead of an adversary. So if you can even get them to have that conversation with you to begin with, in some ways that's a win. Because usually they don't talk to their security teams about the libraries they're going to use. Yeah?
So on the development side, if you say I can't use the PNG vulnerabilities, my response is, okay, so you want to add another year for development time so that I can implement my own PNG? And I don't think I'm going to do better than what the kit standard is.
I actually wouldn't say we should build our own. And the reality is, and it's something Jake talked about, and I'll let him, if he wants to add on as well. I wouldn't say, for security purposes, this library is absolutely unacceptable. I would say here's the cost of taking that on, and here's what we have to do to support it. Now, if there is a technology where there's more than one library, and it's a competitive decision, we've got library A or library B, we could use either one, then you might win on the security argument.
Yeah, I think both questions, it comes back to money and making that business case and talking about what the ROI is, right? So, if you're going to go and say, hey, there's all these incidents coming in, those are just numbers, you put it into dollars, and then it makes a lot different. So you're going to say, hey, it takes a year. Okay, well, what would that take if we hired someone to do it? What's it going to look like? So I think if you pull it all together and sort of show that it sucks, but a business case for it, then you can say, we're going to use it, but we're going to spend some money on some of these other tools, or we're going to put some people on and that sort of thing. I think that helps.
One other thing that I see a lot is when you update the library, you're not just getting bug fixes, you're getting other changes to the library. Yeah. And that means you have to update the rest of the code, which means you have to update other libraries, so it's kind of
Yes. Yes.
Absolutely, and that's why if you don't do it on a regular basis, all of a sudden you're 5 releases behind and you need major architectural changes to get up to current because, oh no, there's Heartbleed. And we don't have a point fix for that. We have to upgrade, and that means we have to do a lot more work than if we'd been keeping on top of the incremental updates. And so that's the other thing a lot of development teams, you know, okay, it's pay me now or pay me later, and there's interest if you make me pay you later. So and sometimes it's just better to keep on top of the incrementals.
Yes. So you're hitting on a whole other conversation, and the quick answer, so the question's really getting into software liability, right? Is at some point when people get hurt, whether it's what we'll call BIPD, bodily injury or property damage, with shit code, someone's going to be liable for it, right? And you're spot on. There's been so many cases with cars, right? You get bumped in the back and it blows up, you know, and we decide, oh, we'll pay people off. And I personally think that's coming, right? And not everyone's happy about sort of software liability, but the whole Internet of Things, and when people start getting hurt, people are going to care. And that's a big difference than some credit cards go missing. So at some point, yes. Now, if you look towards the traditional sort of product liability, what ends up happening? So in what's going on now with tangible sort of property and products is that the final product is what is liable. So for example, if I'm a car manufacturer and I decide I'm going to shove Android in there and that's what leads to a crash and hurts people, it's the car manufacturer that put all the pieces together that's liable. And so if that starts happening, as we suspect at some point, and just because you clicked a EULA, you know, you're not out of it, those manufacturers then will start putting pressure on the software providers. So I think it's coming, and I think sort of, again, when you move out of sort of the data world and you can start impacting property or people, we're going to see more of that. So stay tuned, right? Anything else? All right, well, thank you for your time. Appreciate it.